Okay. All right, so let me reopen LabVIEW. Let's see. Select. Cancel it, I guess. Cancel. Okay, so I'm going to go ahead and put the two arrays and the graph again, and then we'll use the for loop, and then I'll show you the logic. So data containers array. This is my first array, data containers. Oh, you guys can see my screen or no? Let me stop sharing and start sharing my whole screen. I think I was only sharing. All right, so now you should be able to see everything. And graph. Graph. Express XY graph. All right. So this is my X. This is my Y, or f of X. F of X. Save. X. X. Okay. And I think the equation, we can put down any equation. So let's say my equation is f of X equals 2 cosine of 5x sine of 3x. Let's say this is what I want to plot. And I want to populate the values in the arrays, and of course, plot this equation in the graph box. So as I mentioned, first we have to put numeric indicators to make these arrays indicator arrays. Now, if you want to use the arrays as control arrays, then you have to put the numeric control in these boxes. But I just want to populate values that I will calculate through my program in X and Y, X and f of X. So I'm just going to use numeric indicator instead of numeric control. But if you're entering the values manually, then you have to use numeric control. And this is my block diagram right here. So I'm going to go and put this again. Let me put it side by side, right and left. So this is my XY graph. I'm going to take it here, my X, and I believe my Y or f of X array is, where's my f of X array? Right. So that's my fx. And I can keep it on the right side because I'm just have to populate the values in these. Okay. And now to calculate values, we need for loop. So I'm going to go ahead and plug the for loop and extend this loop here. All right, so as I was discussing, n is the number of times you want to run the for loop, and I is the iteration count starting from 0. I is what you have to use to calculate values. So I is very important. And you have to manipulate the value of I in order to calculate the values for the equation that you want to evaluate for the correct range of x. So we were doing x is equal to 0 to 10, and our interval was 0.1. So total we were calculating 101 points. So I'm going to go ahead and put this here. and I'm going to put 101 points over here. So total, I'm going to run this loop for 101 times. Now, when I run this loop 101 times, I value is going to change from 0 to 100, total 101 points. And you have to go from 0 to 10 for X. I is going from 0 to 100. So what I'm going to do, I'm going to go ahead and multiply this value of I by 0.1. And now, when the iteration count is gonna be at 0, the output of this multiplication block is going to be at 0. And as iteration count is gonna go 1, output of X will be 0.1, iteration will be 2, output of 1X will be 0.2, all the way up to an iteration is gonna get to 100, then 100 times 0.1 is going to be 10. So when iteration count is changing from 0 to 100, the value of the output of this multiplication block is going to change from 0 to 10, and that's what we want with a step size of 0.1. So this part is the most important part when you're plotting something. If you can do this part correctly, that is, if you can generate your value of X from the iteration count correctly, basically rest is very simple. So make sure that this is very important for you. All right, I'm going to go ahead and I'm just going to use a formula block to save time instead of putting individual thing. So I'm going to go ahead and use arithmetic, and I'm going to use a formula block and put it here. And my formula I'm going to put is 2 times cosine of X times cosine of 5X, 5 times X, sine of 3 times X. And I'm going to take label X1 to be X. So this is my f of X. And this is my X. It's going to go to X. And this is going to be my result, which is going to go in Y. And my X input is this X. So I'm going to go ahead and I'm going to connect my X input right here as well, so that it's going to plot it. Come on. Right here. And likewise, I also want to populate the values in my 2 arrays. So this is my X array. I'm going to connect this X with this X. And I'm going to connect, where's my Y? Where did my Y go? Right here. And I'm going to connect my Y with my Y values, which is right here. So this is basically the logic behind this program. So once again, important thing is this, how you're going to generate the value of X from the iteration count. That's extremely important. And then I'm using formula block. If formula block you can use as well. If you want to use individual blocks, you can use them as well. Sometimes it may be required to use individual blocks based on the formula or the situation. But in this case, I don't see why formula block would not work. So I could just put the formula and then make the values calculated through the formula block. Anyways, let's go back and run this program to see how it works. So if I run this program, as you can see, the graph is calculated and the graph is generated, and all the values are calculated in these arrays. And you can go to any value. Let's say you want to look at 91st row. Then you can go to the 91st row, which will be the 9 value. And likewise, you can do the same 91st value. Remember, index starts at 0. So if you go to 90th index value, that's the 91st value of your equation. And all these values are plotted here. You can call this plot 0 as your f of x, so that you know that this is the plot of f of x. In case you're plotting multiple plots, then you can call one f of x, the other f1 of x or whatever, or g of x or whatever. So this is how the plotting works, very simple. So right now the interval was given to you. What about if number of points are given to you? Let's say it is given to you plot 300 points between 0 and 10. Then how you're going to do? Let's say if you're plotting 300 points, then first of all, the value of n should be 300 because you have to run it for 300 times. And then you have to choose the interval properly such that between 0 and 10, you have total 300 points, including 0 and 10. So how do you choose that interval? Again, based on the value of I value is going to change from 0 to 299, right? When you have 0, output of x should be 0. When you have 299, output of x should be 10. So operation is very simple. If you multiply the iteration by 10 over 299, then the value of x, when iteration count is 0, x will be 0. When iteration count is 299, x is going to be 10. And in between, it's going to change from 0 to 10. Total 300 points. So this is what you will have to do if you want to go from 0 to 10 and you want to plot 300 points instead of 101 points like we plotted last time. So either the step size will be given to you. Based on that, you can calculate how many points you want to plot, multiply iteration by the step size to generate x, or the number of points will be given to you between the two limits. And then all you have to do is multiply the iteration count by the final value of the limit and divide it by the final value of the iteration count. And then you can go from the initial value 0 all the way up to the final value. If you want to plot not from 0, but let's say from some other value, 2 or something, then you can add basically 2 to the iteration first. So instead of multiplying directly, you first add 2 in iteration, and then you multiply by 10 by 299. So you're going to go from 2 all the way up to whatever value it's going to be there. Let's say if you don't want to plot from 0, you want to start plotting from 1, then all you have to do is to add 1 into the iteration count, and it's going to go from 1 to that value that you're plotting. So 1, 2 in this case, 300, instead of going from 0 to 299. So again, it is important that you play with this iteration count in order to generate the correct value of x that you're using to plot to evaluate an equation and plot any graph. That's the most important part when you're plotting. So yeah, I was doing this. So let me go ahead and let me delete this. So we want to plot 300 points between 0 and 299. So what I'm going to do here, let's close this. What I'm going to do here, instead of this, I'm going to go ahead and do numeric constant, and then another numeric constant. So this is my 10, and this is my 299, and I'm going to do the division. 10 divided by 299, and then this is going to be multiplied right over here. So as I discussed, now when I is going to change from 0 to 299, then it is going to be multiplied by 10 divided by 299. The initial value is going to be 0, and the final value is going to be 10, and that's going to be the x value. graph got a little cleaner because we are plotting more points. So it gets a little sharper, a little smoother. Before we were plotting only 101 points. So you had some sharp edges in the plot, but now we are plotting a lot more points. So the graph got a little cleaner. So keep this in mind that this is the main thing that you have to play with when you are evaluating equation and plotting equation. If you want to plot multiple plots in the same screen, how are you going to do that? So let's say you also want to plot g of x equals, let's say 3 sine of 4x cosine of 6x. Let's say you also want to plot this plot. Gx is equal to 3 sine 4x cosine 6x. Same range, everything. So this is my fx. I'm going to go ahead and grab another formula block. And I'm going to call this my gx, 3 times sine of 4 times x times cosine of 6 times. And this is my x. So that's my g of x. And I do the same thing. I put x over here. This is my x. And I cannot put result directly. Of course, as you can see, I have only one input. I cannot put result directly. Oh, my x is not connected anywhere. Oh, no, it is connected here. So if you're plotting multiple plots, what you do is, let me delete this, and I'm going to pull another. I'm going to pull another array to populate the value of gx as well. So numeric data containers array and numeric indicator. And here the values of gx will be populated. All right, so what you're going to do, I'm going to go ahead and remove this wire. Oh, this is my gx. I'm going to grab it and put it here. I'm going to go ahead and remove this wire. I'm going to go ahead and remove this wire and remove these two. Okay. And gx, of course, is this. So I'm going to connect this here. That's gx. So I have two values of x and I have two values of y. Well, I want a value of x, but I have x and gx plot and x and fx plot and x and gx plot. And you have only one input of x and one input of y. When you have this situation, what do? You use, let me go to tutorial and show you. You use something that we call, right here, a build array block. You use something what we call a build array block. And in build array block, as you can see, you are building all the x's array in one and all the y arrays in the other. So the output of the build array block is going to be the first value of x and the first equation of y. That's going to be the plotted first. And then the second row of x and the second row of y. That's going to be plotted next. So when you're doing multiple plots, whether 2 plots, 3 plot, 4 plot, you're going to use build array block with the express XY graph. So let's go ahead and do that. So I'm going to go ahead and grab a build array block, and I always forget where it is. So I'm going to go ahead and search build array right here. It's under programming array. So I'm going to put one build array for X and one build array for Y. And by default, build array block has only one input. So to make it have multiple inputs, you just have to stretch it down. And I'm going to stretch it to make 2 inputs, and I'm going to stretch this to make 2 inputs. And now the first build array block, I'm going to connect both with X. So I'm going to connect with X and with X. And the second build array block, I'm going to connect with the first G of X and then f of X and then G of X. And move this in so it won't. Okay. So now the wires are not overlapping. And then the output of the first build array block is going to go to X input, and the output of the second build array block is going to go to the Y input. And now when we run it, then you have f of X is white. As you can see, this is white. And I'm going to stretch this as well. And plot 1 is my G of X. G of X. So G of X is red. So white is f of X and red is G of X. And all the values of G of X are populated here. So this is how you're going to do multiple plots. If you are using express XY block, then you will have to use the bundle block, the build array block, sorry, not bundle, the build array block. And in the tutorial, it has shown you basically everything. For a different function, this is a different function that I'm plotting here. And I'm not using formula block. But formula block or not, process is the same. All right, the last thing I want to show you before I go over exercises is how you can use cursors in LabVIEW. Like you used cursors in PSpice to observe values. You can also use cursors in LabVIEW to observe values. To activate cursors, you go to visible items and put cursor legend. And the cursor legend is going to appear over here. I'm going to move it under the block. Cursor legend will also have these buttons that you can use, but I don't really use it. So this is my cursor legend. As you can see, it has X value, it has Y value, and those values are going to appear here. Right now, there's nothing in the cursor legend. Now to assign cursors, again, you have to go to the properties of the graph, right-click properties, and then go to cursors. And then add a cursor to the graph. Cursor 0, I'm going to call cursor 0. I'm going to assign cursor 0 to f of X. So f of X. Cursor color you can change. By default, it is yellow. Cursor thickness you can change, style you can change, and all those things. Now this is important. It says 2 options, free dragging or single plot. Free dragging means you can drag cursors whichever way you want, in whichever direction you want. And single plot is going to move the cursor along the plot. I usually go with single plot. and assign f of x to single plot. And then I'm going to assign another cursor to measure g of x. So I'm going to go to properties again, and I'm going to add another cursor. I'm going to call this cursor g of x. And I'm going to change the color of the cursor to, let's say, green. I'm going to go to single plot and then choose my g of x instead of f of x. So now I have two cursors. I have a green cursor and a yellow cursor. You can see the cursors, like in PSpice, they are on the left-hand side of the screen. So you have to drag them out. One cursor, observe it is moving along the g of x graph, along the yellow line, along the white line. And the other cursor, which is the green cursor, you pull it and it is moving along the red line, which is g of x. And every time you move it, of course, you can see the corresponding values in the cursor legend window. The default precision is only 1 decimal point, but you can change the precision. Again, properties and display format, I believe. Yeah, right here is 0.1f. So if I do 0. Let's say 4f, then let's see if it will change it or not. So it's going to change the precision to 4 decimal points after four values after the decimal point. For x, you can do the same for y. Let's go back and see properties and display format, time axis, and amplitude axis. Again, if I do 0.4%, that's going to change the precision of y as well. So you can change the precision of y and export. Now remember, all these values are the one that you calculated already. They are in the arrays, because it's not going to show you any value that you have not calculated. But again, you can use cursors and you can go to a specific value of x or close to that value of x and observe the value of y for that specific waveform that you are looking at. So in this one problem, I attempted multiple things. I showed you how to use arrays, how to create arrays using the array block and then numeric indicator. Again, these are the arrays that you are using to display values. If you want array to enter values, you have to use numeric control instead of numeric indicator. Then I showed you, of course, how to use express XY graph to plot a single plot, and then to plot two plots with express XY graph using build array. And then, of course, how to read values in cursor window. Now let's go to the text and see what you have to do. So we discussed already one problem for the matrices. Okay, so in this two-dimensional graph, this is simple. I'm plotting between x and y. These values are already populated from this equation. So in this case, I'm creating arrays. These are control arrays. So I'm putting all these values in these arrays, and then simply using express XY graph to plot between x and y, which is simply this. So no for loop, nothing, because all these values are already calculated, and I entered these values manually. So you don't really need the for loop for that. You need the for loop if you want to generate values. But I already generated values and entered everything manually. Now, there's also an XY graph instead of express XY graph. So if you go to, again, if you go to your graph under model, express XY graph is this, and XY graph is this. So if you're using XY graph, and if you go to your block diagram, observe that XY graph does not come with any of these, the blue block that you see with the X input and the Y input and whatnot. It only shows one input. So if you're using XY graph instead of Express XY graph, now if you use the graph from the Express library, that's always going to be Express XY graph. This graph is always Express XY graph. But if you use the graph from modern library, then you have the option of Express XY graph versus XY graph. Actually, let me go to Express and see what is the other one. This graph. Maybe this is the regular XY. No, this is the waveform graph. Of course, that's different. Waveform graph is different. Might be the same, actually. It has one input. But in any case, if you're using XY graph instead of Express XY graph, then how do you plot X and Y? You use a block called bundle block. And the bundle block is right here, programming cluster class invariant bundle. So it's in this library. So you use a block called bundle block, and you bundle X values and Y values. Output of bundle is single value or single array, which goes into the XY graph, not the Express XY graph. And then I introduced for loops. In this case, I'm just plotting from 1 to 100 in this array. Simply, I'm adding 1 into the iteration count. So iteration count is going to go from 0 to 99. And when I add 1, it's going to go from 1 to 100. And array is going to show all those values. Exercise 13 is your next exercise. In this, you are generating a multiplication table. So use a for loop to generate a multiplication table from 1 to 10 for an integer n. So this is the front panel of your multiplication table. You have a numeric control that will determine the number for which you have to generate the multiplication table. Right now it shows 4. So I'm generating the multiplication table of 4, but you can change this number and the multiplication table should correspond to that number. All you're using is for loop. You're running the for loop for 10 times, 1 to 10, and you're multiplying the iteration count by this, and then generating the result. And these 3 are numeric indicator arrays because you're populating values for, which is in this case, n and I and n cross I. So the only numeric control here is this n, and the rest of them are numeric indicators. Arrays of numeric indicators. So you're going to use for loop to create this program. I discussed with you already how to do graphs using for loops. Exercise 14, you are doing a graph for y is equal. Yes, go ahead.
Ones we can use the calculator, right? Or the whatever, I forgot what it was, the formula block, right?
Yes, you can use formula block. I'm using it here, so yeah, you can use formula block. All right, create a graph for y is equal to 2 sine x cosine 5x for 0 to 0, x is equal to 0 to 360 degrees. Make sure that your x-axis should be in degrees. Remember that all trigonometric functions in LabVIEW take their argument in radians. So in this case, your x is one complete cycle, 0 to 360 degrees. And then you're plotting this trigonometric function, you're plotting this equation, which has 2 trigonometric functions, sine and cosine. But remember that you cannot directly put x as degrees in the value in the box of sine or cosine. Or if you're using formula block, you cannot put x in degrees. So you have to convert x into radians first in order to calculate the correct values for this equation. But when you're plotting the function, make sure your x-axis should still be from 0 to 360 degrees, or 0 to 359 degrees would be a complete cycle, basically. At 360, the new cycle starts. So whichever way you want to go, 0 to 359, total 360 points. I discussed with you multiple plots, build array block. These are the two plots I'm plotting, 2 sine t and cosine t. I discussed cursors with you already. I also showed you how to change the precision of the cursors, which is not in the tutorial. All right, exercise 15, plot two functions. Y1 is this, Y2 is this. So similar to what we did in the class. Using XY graph, not express. So you're using XY graph here. You're not using express XY graph. XY graph from the modern library. The range of X is from 0 to 8. Step size is 0.01. Similar to what we did again in the class. We took the step size 0.1. I'm asking you here to take 0.01 and go from 0 to 8. Place two cursors, one for each function, and measure the output for y1 at x is equal to 2 and y2 as x is equal to 3. Also, use three arrays to display the generated values of x, y1, and y2. So it's similar to basically what we did over here, where it's a different function. Fx and gx are different functions, but it's the same, except again, the graph that I used here is express xy graph. In that exercise, you have to use simple xy graph, not express xy graph. So how are you going to do that? And one more thing, I'm also asking you to observe specific values from the plot. Now, once again, if I close this program and reopen it after saving it, then everything will be gone. So make sure once you put cursors and once you observe values, make sure you again do data operations and make current values default. If you do that, then it's going to hold the cursor values, it's going to hold the graph and everything. Once you close the and make sure to save it after you do the date and the make current values default, save it before you close your program. Because in that exercise, I'm asking you specifically to observe y1 at x is equal to 2 and y2 as x is equal to 3. So once you move your cursors at x is equal to 2, and the y1 value is going to be in the cursor window, and then move the other cursor to x is equal to 3 and y2 value is in the cursor window. If you don't save that value, or if you don't initialize that value as the current value, then it's going to be lost once you close your program. So make sure you do the current value, save it as the current value. And then you have to use three arrays to generate x, y1, and y2 like we did in our class meeting. Okay, so how are you going to use xy? You're going to use bundle block, and then you're going to make pairs of xy1 and xy2 first. So the bundle block that you saw in here, you're going to use two bundle blocks. You're going to make xy1, and then you're going to make xy2, because you are doing two functions. So you will have to use bundle block to make pairs xy1, xy2 first, and then that will be followed by the build array block that we used in our class. So this build array block. And then the output of each bundle block is going to go to the build array block, the first one on top and the second one at the bottom. And the output of build array block is going to go to the XY graph. And then again, I'm telling you, right click on the graph window, go to the data operation and choose make current values default to keep your graph intact once you close the file. Under properties of the graph, when you go to cursors, choose single plot for each cursor and allow dragging. Like I showed you that it's going to drag along the function. If you don't do that, then it will just go anywhere whenever you move your mouse. That's your second to the last exercise. And the last exercise for next week is that you have to graph a function, quadratic equation, ax squared plus bx plus c. A, b, and c, you're going to take three dials. And the values of each dial is going from -5 to 10. So you make sure you choose the lowest value of each dial to be -5. Upper value is by default 10, but lower value is 0. By default, change that 0 to -5. And then you are going to take the range of x from 0 to 10 divided into 100 points, and then plot ax squared plus bx plus c based upon whatever the value of A, B, and C coming from the dial is going to change the graph live when you are running it, and moving the dials is going to change the graph according to the values of A, B, and C that are coming from 3 dials. So it's a plot of a quadratic equation with the dynamic values of your coefficients A, B, and C. And that's what there's a advantage of using LabVIEW, which is you can change values on the fly and then change things or observe things, how things are going to change if you're changing the values. LabVIEW can do that. In MATLAB, it's a Simulink. Simulink is a program that not comes with MATLAB, but it's a MATLAB program that can also do the same thing. So Simulink and LabVIEW, they're very commonly used in control industry to represent your systems and to show how changes are going to affect when you change different parameters in the system. So this is your last value, last exercise that you have to do. And that will finish the second software, LabVIEW. So again, next week is the exam, and then